Hello, everyone. I'm competing against the keynote, so it's good to see at least some people here. Hopefully more filter in after the keynote finishes, which will be very soon. Thanks very much for joining. My name's James Bayly. I'm the Head of Business Development for SubQuery. Apologise for the thick New Zealand accent. We don't speak clearly in New Zealand. But today I'm going to talk to you about Avalanche Data Indexing Made Easy with SubQuery. So what is this data indexing? Why do we need it? Let's start with that. The key problem here is querying decentralized data, right? In order to build increasingly complex and intuitive applications out there, developers need powerful tools to process and query that data faster. So there's many examples of this, right? If you're building an NFT marketplace, you want to be able to present to your users a list of all the NFTs and the collections, but also the transaction histories of those NFTs, who's owned them in the past. You want to be able to roll up, who owns the most NFTs, who's prolific. Another example is with, a DeFi application, calculating the total value locked. There's many endless possibilities, right? Data is a key ingredient for successful applications, and collecting that data off a blockchain is difficult. And the reason of that is because a blockchain is a glorified linked list. It is a chain of blocks, each block including some unstructured or semi-structured data, but it's messy, it's noisy, and querying that linked list, you have to kind of iterate through each block, do it natively, which can take days, if not weeks to do. So querying data directly from Avalanche isn't feasible. What you need is a data indexer, and that's what SubQuery is. SubQuery is a open source, flexible data indexer. And a data indexer generally has 4 steps. We extract data from a blockchain, in this case Avalanche. We transform that data to fit your needs. We save that data or persist that in a high-performance database, and we allow you to query that using a query language, either a REST API, but for us it's GraphQL. Now, SubQuery this already exists. We are huge in the Polkadot ecosystem. We're the prominent data indexer for Polkadot. We're used by both of the largest 2 wallets there, by their main scanner called Subscan, which is equivalent of Everscan. We're used by many NFT players. We're used by most of the teams themselves index their own blockchains. But we're very excited and very happy to have expanded to Avalanche. And today I'm going to show you a demo of the beta version of our Avalanche integration. So there are 3 main things, and sorry, there's a bit of delay here, but I'll catch up. There are 3 main things that we do at SubQuery. SubQuery, the main area of this is that it's open. Sorry, just catching up. Anyway, we're open, so we're open source, but it goes further than that. It goes to that you can basically change the SubQuery project to fit your needs. So if you don't want to use GraphQL, that's fine. You can just put the data into a Postgres server. You can then analyze that using your favorite BI tools. We're flexible. So a lot of people ask, why not just use a data provider out there? There's many providers that provide data for me. The key one is if you want to build an application that is differentiated from your competitors, that is better than your competitors, that users want to use, you need data in a format that suits you, data in a format that is more advantageous. And so the SubQuery project itself is your custom template, your custom API for your application. It's flexible. It's a flexible scaffold, as I like to call it. And then finally, we're fast. We're absolutely, our team is focused on making SubQuery faster than other solutions with advanced indexing caches and pre-calculated or pre-computed indices. And we do all that work ourselves so that you don't have to worry about it. In fact, a lot of the teams I've talked to in Avalanche in the last couple of days, I asked them, what do you do to solve this indexing problem? Because everyone needs data. And a lot of the teams have said to me that they've built their own indexer, which is like reinventing the wheel. So we're here to help avoid that reuse. So in summary, what we do is the outcomes that we derive is we help with development speed. We allow you to develop faster, to deliver faster, by saving you from rewriting the wheel or rebuilding an indexing protocol. and we provide higher reliability. We're focused single-handedly on making sure that SubQuery is efficient, effective. The queue system is there. It has automatic retries. It's designed so that it never misses a block, it never misses a transaction, and it saves you from having to worry about that. So why now? Avalanche is booming. There's an electric capital report which everyone should look at, which goes into developer ecosystems, and Avalanche is growing at a three times multiple over 2021. Coming to this event, it's just huge. It's great to see the focus here, and then a number of applications coming through, especially in gaming and in DeFi. And all of these applications, all of these ecosystems will need data. We have experience with all the different sectors in Polkadot, and we're looking forward to bringing that experience here to Avalanche. So, what is a subquery project? A subquery project in a nutshell is a set of instructions on how to index data. If you've ever written a graph project, it's very similar. We've designed it intentionally to be very similar. It has the following three main parts. It has a GraphQL schema file, which is the shape of your data. This is the output that I want. This is the API I want in the end. It has a manifest file, which is the configuration. What chain am I connecting to? What am I looking at? What events am I subscribing to? And it has mapping files. And these mapping files are the data transformation pipelines. So let's do a demo. There's nothing like a demo to kind of go through this. I'm going to start with this GraphQL schema file. Now, in my demo, when it catches up, I'm just going to do a very simple demo in the time that we have available, and that is to go through, basically index all the transactions and approval calls for Pangolin. The Pangolin decentralized exchange, I'm sure many of you are familiar with. We're going to focus on that today. So the first step is defining the shape of my data. And this is a very simple example. I want to index transactions and approval event calls. So the data I want from transactions is obviously the value of the transaction, what address it was to, what address it's from, the contract address, and a unique ID, which is the transaction hash. And I also want to index approval events. So the ID, the value, from, who was the spender, and the contract address, of course. So very simple example. You can define this in GraphQL, and if you're familiar with GraphQL, this is the endpoints that come out of it, right? So we will have a code generation process that will generate these GraphQL entities as concrete TypeScript models. So here's my transaction entity that comes out of it. Sorry, it's very delayed. Give it a second. And it has certain helper functions like save, remove, and get. And same with the approval entity. So we have code generated to that. The second piece is the project YAML. So this is the configuration file for my data indexing. And there's a few things here. Is this large enough? Not really. Let me take it bigger. And let's wrap it. So there's a few pieces of this. Firstly, some boilerplate definitions, descriptions, GitHub repositories. It's referencing that schema GraphQL file that I created before. I'm connecting to Avalanche's C chain. This is a Genesis hash. We've got an endpoint running up, and we'll be creating a production endpoint and providing that to the ecosystem, specifically optimized for subquery. And the key one here is that the chain ID. At the moment, it's mainnet, but subquery is designed, from my experience in Polkadot with the parachain architecture, it's quite similar to what Avalanche are trying to do with subnetworks. So we are designing this to work with subnetworks when they launch, and rather than just being indexed for the C chain, we are trying to build this so it's configurable and it will work with any subnet that you define. And the way that will work is basically in here you'll reference the chain ID or the chain alias of that subnetwork that you create, and you'll be able to import. When you create a subnetwork, you basically override your definition of the subnetwork extends, the snowman's block interface and the decidable interface, and you'll be able to import your overrides here so that we'll be able to index that. And then finally, the data sources. So In this piece, basically, we're defining what are we indexing. So we're using the Avalanche runtime. We're starting at a pretty high block number just to get some data through. And we're indexing the pangolin token. So I've got the smart contract address for pangolin. I've referenced an ABI, which is a standard ERC20 ABI, but you can bring in the custom ABIs that you want. You can have multiple ABIs if you're doing multiple smart contracts in the same place. This is just a standard ERC20, but yeah, as I said, you can reference your own custom file. And I'm also looking at two different handlers. Now, there are three types of handlers that SubQuery supports. There's a block handler, and this is the basic one where on every block we do something. It's pretty brute force. We try to avoid it as much as possible, but it's commonly used as well. So on every block, do something. The other two here are, and what we're using today, is an event handler and a call handler. Event handler follows the standard kind of log filters from Ethereum. And the topic filters, those are, as I said, the Ethereum JSON RPC log filters. So you can have up to 4 different topic sets here. In this case, I just have one, which is transfers. And so on every transfer event relating to that smart contract, I'm running a handle EVM transfer, which we'll see later. The second handler I'm doing is a call handler, which is indexing calls on the chain. In this case, it's the approval call for that smart contract. I can either define as a fragment or a signature. In this case, I just have an approval signature. And on every time that happens, we'll run this handler. So that's the second part. So we've defined the shape of our data. We've defined the configuration of when we're going to do indexing and on what events. And finally, what we're going to do is we're going to do the mapping handlers. So the mapping file comes in here. There's two different functions here. There's this handle EVM event transfer, which is on a transfer event, we receive an Avalanche event, which is a small wrapping of basically what we get from Ether, ETH.js. It basically receives that event. I've defined a kind of a custom Ether.js generic definition here just to make life easier. We're going to do some improvements here so that we automatically generate this because it makes life a lot easier. But this is the format of that data coming through. And so when we receive that, it's very simple, right? So we've written in TypeScript to make it as easy as possible. You take that transaction event data, we assert that the arguments are correct. We then create a new transaction entity, which is that GraphQL schema entity that we created before, with the transaction hash as the unique ID. We save the value, the from, the to, the contract address, and we just save that, right? This is all you have to do. Just write transaction.save, all the helper functions do all this stuff automatically. And the same thing with the EVM call, right? The approval call. We receive that data, we assert that when the screen catches up, we assert that the data is correct, the arguments are correct, and we save that the same way, in a similar way. We support doing a lot more complex stuff on these handlers. So this is a very simplistic example, but the teams in our Polkadot ecosystem have done a lot more complicated things. So for example, you can retrieve data from here. A common example would be if you want to continually calculate the day rates or the day values of things, you could save a day volume, a daily volume entity, and you can then request that from the endpoint. And every time you receive a new transaction, you can update that daily volume, you can update the averages. So you can retrieve data through these mapping functions, these mapping handlers. You can update them. The data is not idempotent. And we also are doing an enhancement so that we can save the historical state of entities. So you can continually update these entities, and we'll be able to give you the historical state. So for this block range, this entity had this value, and then it suddenly changed for this value. So all this is very easy. It's all in TypeScript. It's all very straightforward. It would take you, 20 minutes to do. But from this, we can run this. So usually, this is the beta, so it's not released yet, but usually we can use Docker to run this. You can just write docker compose, docker up, and it would spin up the node, the indexing service. It would create a new database with the tables correctly. We use a Postgres database. and it would spin up a query service as well. So usually I can run that with one command. But in this case, because we're using a beta version, I have to run a little bit longer command. So I'm going to first build it, which is this command here. And that's building and packaging the code. And then I'm just going to run it using this command, which again is a bit long, but essentially it just runs the node service and sets a batch size of 10. That endpoint, we're just setting the maximum number of requests going to the endpoint, just so we make sure we don't overload it. And that will start up. I'll just make this full screen or much larger. So it's connecting to the endpoint. In this case, it's connected successfully. It started the node, and it's now fetching blocks. So that's basically it. In the background, it's indexing transactions. You can see I put a logger function here just so we can show that these transactions have actually been indexed. And when it loads the screen here, you can see there's a saved transaction value there. And it's fetching these blocks constantly. If it disconnects from the endpoint, it will keep trying. It will keep running in the background, right? And the way that this works is it indexes as fast as possible up to the latest block, the latest finalized block. And then every time a block's added, it continually adds the new data. So there's obviously an index period up to that point in time. But from that point, you have the real data, and it's always up to date. It's always finalized. I can now query this. So coming over to this one here, I've got a playground. This is running on a query service, which is again provided by SubQuery. Sorry, when this comes through. And if you've ever used GraphQL, it's really simple. Think of it like writing SQL commands that are safe over a web endpoint. It makes life very easy. In this case, I'm doing a very simple request when the screen catches up to Windex to request a list of transactions. In this case, the first 5 transactions. Again, when it catches up. And you can see I've got a list, an array of transactions. I've got 128 transactions been indexed so far. It's still catching up. But I can do some pretty cool things like, for example, order this by the amount descending or the value descending, which will then change that. I can add filters, so I can say, give me all transactions that from or to this account. Let's say filter 2 is equal to this account, and that will get me a list of all transactions to that address, of which there are 28. So yeah, very simple. If you want to use a wallet and show the history of all your transactions, Pangolin, or the interactions that smart contract, here's a data point for you or data source for you, right? And it's very straightforward. So you can take this further, right? You can index multiple smart contracts. You can index multiple events. You can combine those. It's really a blank template to which you can use for your application in a way that you want. So that's really SubQuery, right? It's open. Now, we also provide quite a few different services. So you saw the SDK, what we call the SDK, a software development kit. It's open source, it's free to use, you can change it. We've got customers using it all, running it on their own infrastructure, and we provide all the documentation to do that. But we also provide a managed service, right? Teams like yourself who want to be building new applications, you don't want to be running infrastructure. Running infrastructure is a nightmare. So we provide a managed service where basically you can give us your SubQuery project, and we will deploy that and run that in our own infrastructure on AWS. We'll manage that, we'll make sure it's online and available. And we're currently serving hundreds of millions of requests for different applications in Polkadot every day. So this is a huge scale that we're running at the moment, a managed service. And when we bring this, or with our work on Avalanche, your Avalanche SubQuery projects will work in this managed service. So SubQuery is not just a tool that makes it easier to index data. It's also an infrastructure provider to give you that data in a way that you don't have to wake up at 2 in the morning when something breaks, inevitably. So we're doing hundreds of millions of requests. We have a website, an Explorer actually, where you can go through a list of all the different projects. And unfortunately, a lot of these projects won't be familiar to you guys because obviously you're from the Avalanche ecosystem, but these represent some of the biggest DeFi projects, some of the biggest NFT projects, decentralized exchanges, wallets, scanners, and Polkadot. And we expect to get a lot of similar teams from Avalanche as well. So that's the managed service, free hosting for your projects. We'll run that infrastructure for you for free, but the common question is like, look, this is centralized still, right? The whole point of a decentralized application is that we don't rely on someone to run it, because there's nothing more embarrassing for a decentralized application is when it goes down because a centralized service that it relies on has failed. So we are building the SubQuery network. The SubQuery network is the future of Web3 infrastructure, and it's something that we're working on right now to build. And basically how it works is that you can build a SubQuery project, you can take it out there to the network, and you can offer it to network to index. Indexes on the network can go off and index this project, and by rewarding them in the SubQuery token, you can then make requests to them. So you'll have indexes around the world running the infrastructure for your decentralized application. You can query to any of their endpoints, and we're building it in a way that you can query it to one CNAME, and it will be routed to the nearest indexer. So as a result, you also benefit from essentially think of SubQuery as a CDN, right? Because it's read-only data. So the whole point of a CDN is having a lot of nodes close to your users, and rather than requesting data from one server, we expect the SubQuery network to massively improve the performance in terms of the latency of applications out there in the network. So the SubQuery network, decentralization, and the tokenization of that network is the next big step for us. We're working on that right now. We expect to launch our test network in just over a month's time. And again, you can completely decentralize your application stack and incentivize your community to run your own infrastructure, be a part of the application that you're building a lot more deeply. So one thing that the SubQuery network that our competitor, for example, doesn't do is that it's multi-chain by design. We're designing the SubQuery network to support any SubQuery project from any layer one, whether it's Polkadot or Avalanche. There will be a unified SubQuery network, a single network, but it will be able to run projects from any layer one that we support. So you'll benefit from that scale. It's simple and accessible. We'll look at the token economic model. The way that we're building it is to make it easy to participate, both as an indexer and as a consumer. There's no crazy high minimum staking thresholds to become an indexer. And we're taking a lot of focus on the user experience to make it really easy to play a part and to publish a project, but also to sign up as an indexer, because things are quite complicated out there. And we are innovating in payment methods. So at the moment, if you go out there into Web3 and you pay for a service, it's generally transactional pricing. You pay per request, or you pay per packet of data that you want, or transaction. The SubQuery network, we're working to provide a third different transactional way to pay, which is basically modeled off the subscription services that we operate in Web 2. So a consumer of data can basically agree with an indexer to request a limit of tokens over a month, a limit of requests over a month, and the indexer will agree to provide that. So I could say to an indexer, look, I'm happy to pay you 20 SubQuery tokens to get 1 million requests a day for 30 days. And you can make as little or as many as you want of those 1 million requests. It just makes a lot more sense. That recurring payment model is a lot more attractive to both consumers, but also to indexers, because it's a reliable, guaranteed, steady stream of income, or an understandable amount that you're going to pay. So that's the SubQuery network. We're doing a lot of work there. It's really exciting. Why use SubQuery at all, I guess, is a final question. There are a few other options in this ecosystem already. Why use SubQuery? So there's kind of two other options, really, apart from running your own indexer, which is a terrible idea. The first one is a standardized data service. There's quite a few providers out there of data. The problem is that you what you're given. You can't really change that. You can't say to them, look, can you please change this property so I can get this piece, or aggregate it in a slightly different way, because they'll probably laugh at you. So SubQuery is flexible. It's open source. You can customize the shape of your data to be what you need for your application. And of course, those other providers are not necessarily decentralized. A lot of them are centralized. You're relying on that centralized provider. With the SubQuery network, we're going to provide that decentralized alternative. And then there's other providers, of course, that are quite similar to SubQuery in terms of they're an open GraphQL decentralized provider. It's flexible. And there's one here already, but we've heard there's a lack of developer support. And there's some performance issues, especially with their managed service. We've heard a lot of issues around massive outages that have gone on for hours, and you guys can't deal with that, right? Like, you're running a business, you need an application so it's online. We hear about that, and we've got a lot of focus on the SubQuery managed service. Over the last 3 months, uptime I think is 99.95%. We do a lot of enterprise support for those big customers, including multiple databases, read-write replicas, full-back query services. So we really focus on the enterprise level of support. And of course, these other open data services, these other flexible ones, don't have any plans right now to cover Avalanche's subnets, right? This is one of the big pieces, this is one of the big unknowns, and this is one of the big focuses of Avalanche, is the subnet support. And our expertise in Polkadot means that we know how to build a configurable, extendable platform that allows you to index your own subnet, right? Because a lot of teams are planning on building their own subnet, and they're going to need data on that subnet. So it's really exciting for us. Our roadmap right now, we're undertaking final testing. That demo I showed you is almost ready. It should be ready in the next couple of days. We're starting up the contract chain. That's where a lot of the stuff is. Then moving to the exchange chain, and then working on the platform chain with all its subnets. So this is our kind of roadmap, our step-by-step. We're moving pretty quickly, but really excited to share where we're at right now and our plans ahead. It's so slow behind. Finally, what we intend to deliver. So we've got advanced ETH-based contract and log filtering that you've just seen. We're providing something called dictionaries, which are pre-computed indices, and they dramatically reduce your indexing time. We've done a lot of work on in speeding up the initial indexing time, because it's the main problem. Full support for Avalanche and our free managed service I showed you before. Intuitive documentation. We have a huge documentation repository, because basically you need to build your SubQuery project yourself, and we can help you. We provide a lot of support, but documentation is one of those things that a lot of teams talk about, but we really focus on documentation. And that includes a step-by-step learning course that we're going to build for Avalanche. We already have one for Polkadot. We're going to have a step-by-step learning course for this ecosystem. And then full support for Avalanche in our upcoming SubQuery network. So where we are now, we're looking for launch partners that we can support as they develop their first SubQuery projects in this ecosystem. It's very early days, but basically we want to work hand in hand with teams out here. There's already a lot of teams I've talked to. Reach out to me at that email. I should put my Telegram handle up there, or come talk to me after. But basically, we want to handhold you through and make sure that what we're building works well. Because we're new to this ecosystem, and there are a lot of unknowns, I guess, for us still. But we're keen to learn as fast as possible and make sure that we support the ecosystem. So really excited about this. Thank you very much for your time. That's us. Any questions, I guess, from you guys? We can just talk to me after. Sure.
Do you support any other networks besides Polkadot and Avalanche?
Yeah, so we've got a plan to support, we're moving pretty quickly here at the moment, where we've got plans to support, we've got 5 identified, and really, I won't name them, but basically, we're looking for networks that aren't necessarily, we call Generation 3 networks, so where a lot of the new developments going on, where a lot of the new ecosystem growth is happening, and that aren't necessarily a layer 2 on Ethereum. So we're not kind of going towards the layer 2s or Ethereum networks, we're looking at these other ones.
Is it possible to customize customize your code to support the
Absolutely. So it's
previous
open
versions?
source, and a lot of teams have. I've got examples of teams that have taken the core SubQuery node service and just thrown away the rest. And so they've put that node service inside their own application, and they've built some pretty interesting BI tools on top of that to get that data, and kind of like a Nansen style data warehouse.
Okay, I have one more question. Do you support subscriptions and web
Yeah, we do subscriptions. We've just released support for GraphQL subscriptions. We are putting that into a managed service as well, so that you can subscribe to a project that someone else has built. So that's the best thing about the managed service, is that we make public, or we by default try to make public all the projects. So you can go on there and you can see examples of how other people have done things. You can see how a big wallet is doing it, or another exchange is indexing data. It's all kind of open, which is what we're trying to do, right? Is build this open data marketplace.
Thank you.
All right. Thank you, everyone. Thanks very much for joining, and